Hello, my name is Stuart Kauffman. I'm a rather antique American biologist. I've taught at a number of universities, published about 350 papers and 6 books. I want to talk about a major subject today of major import. It's the global economy and the Anthropocene. In this brief set of comments, it's impossible to mention all of my collaborators, but I do want to talk about Roger Koppel, an economist at the University of Syracuse, and Brian Arthur, whose book, The Nature of Technology, is a central part of these issues. Brian has talked about combinations in technological evolution. To be blunt, here's the issue. Our global economy is $100 trillion, and it's growing at between 3 and 4% a year. It's expected that by the year 2100, it'll be tenfold as large. The global economy is lifting millions out of poverty. It links our globe together in webs of international trade, and it provides the means by which almost all of us earn our living. It's the result of the cumulative human, technological, and cultural evolution for 3 million years, as I'll describe later. The unintended consequence of this is that the same juggernaut growing economy is driving the Anthropocene with drastic climate change that we all know about. But far worse, the same growing economy is driving a mass extinction event, which I'll again describe in more detail in a moment. The issues that we confront are global and civilizational in scale, and they are existential. We're destroying the biosphere. Humanity has never confronted issues on this scale. If we do not look the issues squarely and understand what we are doing, we have no chance of confronting and ameliorating the future that we now confront. It is not at all clear that we will manage to do so. Our juggernaut economy, for all kinds of reasons, is likely to continue to grow. That is why what we confront is global in scale, civilizational scale. This is the first world economy doing its thing, and existential. Climate change and extinction event underway are existential threats. The human species is badly out of balance with the rest of the biosphere. There are 7.7 billion human beings now. Most species have numbers ranging from the tens of thousands to the millions, not billions. Recent reports show that on the order of 1/3 to 40% of terrestrial landmass is given over to growing our food by which we feed ourselves. How much land mass is given over to sustain the livings of frogs, or forest elephants, or giraffes, or rabbits, or raccoons? We don't know, but it's very small compared with the fraction of the planet that is sustaining us and feeding us. Another stunning fact that I've learned recently, I have not been able to exactly confirm the details, is that the biomass, the weight of all of the animals on land, animals and plants on land, more than 50% of the biomass of the terrestrial world are humans and our domestic products, our cows, our chickens, our pigs, our wheat, our barley, our sorghum. Just think of that. More than 50% of the biomass of the terrestrial world are humans and our products. How much of the biomass is rabbits? We are overwhelming the biosphere, and if you need anything more to convince you of it, I can't imagine what it would be. We are in the Anthropocene. The Anthropocene is a newly demarked era in the history of life on Earth in which humanity is changing the biosphere. Climate change is now well upon us. It is now widely known. We now confront rising sea levels, ocean temperatures warming, acidification of the oceans, coral reefs bleaching, flooding, mass migrations, forest fires. At least climate change is now well known, and we are considering what we can do about it. The recovery from climate change may be on the order of hundreds to thousands of years. Far worse, and receiving much less attention, is the mass extinction event now underway. In May 2019, after 2 years of study, the United Nations issued a report on extinction. It's expected that by 2050, a mere 30 years from now, 20%, or 1 million species, which is 20% of the standing diversity of all species, will be extinct. This is on its way to being a mass extinction event, where a mass extinction event is the destruction of 75% or more of the standing diversity. There have been 5 such events in the last 550 million years. The largest extinction event was the Permian, 255 million years ago, in which 95% of all species went extinct. We have no idea how vast this extinction event that we are causing will be. Bear in mind that before a species goes extinct, its population's numbers dwindles. There's abundant evidence that for very many species, their population numbers around the globe are dwindling rapidly. The recovery time from climate change may be thousands of years. The recovery time from mass extinction is millions of years. We will not recover from it. Now, what's causing this mass extinction? We only partially know. Part of it is the invasion by our growing economy of virtually every habitat, the disruption of habitats, overfishing, overgrazing, almost certainly monoculture agriculturally, runoff of nitrogen fertilizers into our seaways, coming out of the forest of new kinds of viruses that will infect us. This is a massive event. As I said before, the global economy, growing at 4% a year, is driving this mass extinction. We've never confronted anything like this. We better do so, but it's not clear that we will. It's important that we truly tend to think that we do not significantly impact the biosphere and the planet. That's false. The rate of technological change is exploding. I was born in 1939. When I was a child, milk was delivered in glass milk bottles. Plastic came into use about 1960. In a mere 60 years, plastic befouls our oceans, befouls every ocean shore, and fills our landfills across the planet. Plastic is not evil. It was, in fact, progress as it was introduced, and it's used for many good things, and many people make livings making, buying, and selling plastic products. Nobody foresaw the consequences. The difficulty is that we typically do not foresee the consequences of what we do, and even if we do, the economic opportunities are so vast that we seize the opportunity and march ahead. Planet, 50 years later, be damned. The Anthropocene is an unintended consequence of the cumulative, wonderful creativity of our species, Homo sapiens, and it started 3 million years ago with our ancestor, Australopithecus. Australopithecus had maybe 10 very crude stone tools. The archaeological record shows that over the last 3 million years, Australopithecus gave rise to Homo erectus, then Homo habilis, then Homo sapiens about 300,000 years ago. The number of tools and their differentiation into simple and complex tools was extremely gradual. It took hundreds of thousands of years for knife blades to increase in length by an inch or so. So the increase in diversity, number, and differentiation was glacial. But in the last few hundred years, it has exploded so that there is a hockey stick explosion in the number of goods and services in the economy to billions now, and their differentiation from a few simple tools to more and more differentiated tools, simple to complex. So now we have billions of tools ranging from needles and knitting needles. Needles have been around for 60,000 years, through bicycles and cars and television to aircraft carriers and the space station. By and large, we have no theory or deep understanding of how cumulative technological and cultural evolution has gotten from tens to, in the last several centuries, billions. I'm going to present you in a bit with the first theory that I think that we have of this process. It's driving the Anthropocene. The explosion in diversity of tools is, in the last several hundred years, after a glacial increase over millennia, and in fact over hundreds of thousands of millions of years, is just one example of what I will call hockey sticks in human cumulative cultural evolution. This includes not only our tools and their diversity, but our architecture, from caves to simple dwellings, to increasingly complex dwellings and architecture, to the trade towers a few years ago. The same thing is true in the evolution of our musical instruments. Neanderthal had drums and flutes 60,000 years ago, as did sapiens. The evolution of music is the same differentiation from a few simple to many complex tools, instruments, and music. The same thing is true in art. The same thing is true in science. Think of the flowering of science from the time of the ancient Greeks working out trigonometry in the Nile Valley, to Euclid, to the enormous explosion of science in the last few centuries. They're all hockey sticks. The structure of legal law is the same thing, from before Hammurabi to Hammurabi, to the enormous diversification of constitutions and laws around now. What's driving these hockey sticks? Among the most important hockey sticks has been the growth of global GDP, global domestic products. GDP was stable for roughly the past 300,000 years at something like $200 or $300 per person per capita. It started to explode about 200 years ago and has been going up ever since. It's a hockey stick. The same thing is true, as we will see in some graphs in a moment, of human population. Human population stayed constant and has exploded in the last 2 centuries, from less than 1 billion to 7.7 billion now. The same thing is true of urbanization. There was little urbanization until about 1870 or 1850, and it has exploded upward. It turns out that urbanization scales with the logarithm of per capita GDP, and as we will see, per capita GDP also exploded in a hockey stick about 150 years ago. It's deeply interesting to just look at some of the collected images by archaeologists for the past 3 million years. The first is a unifacial scraper found with the skeleton of a 16-year-old girl, Australopithecus, about 2.6 million years ago. Homo sapiens emerged 300,000 years ago. It took 250,000 years to get to Cro-Magnon, about 50,000 years ago, at which time we have pressure flaking, and you see images of beautifully pressure flaked knives and polished tools and so on, where the diversity of tools has increased from the 10 or so of Australopithecus to several hundred, ranging in complexity from arrowheads to the atlatl, the spear thrower, a bit like a lacrosse stick that allowed Cro-Magnon to throw spears at aurochs rather than thrusting them in by hand. Several thousand years later came the agricultural revolution, and with it, taming of grasses and the onset of surplus wealth and the first empires. In Mesopotamia, about 4,000 or 5,000 years ago, there were perhaps 1,000 or so tools ranging in complexity from needles that Neanderthal had 60,000 years ago to chariots. Notice the increasing differentiation from simple to complex goods. Chariots are a lot more valuable than needles. With the development of increasingly complex and valuable goods comes an increasing diversification of human society into the emergence of social and wealth inequality in power structures. We now have, in 2019, billions of tools ranging from needles and thimbles to the space station, of which you see an image with some Russian cosmonauts. It's overwhelming. I also want to point out, again, the exploding pace of technological change. It was glacial for a long time. It's extremely rapid now. One way that I realize this is the following. My father was born in 1903, the year that the Wright brothers invented the airplane. My son was born in 1969, a mere 66 years later, the year we landed on the moon, by an entirely different technology than airplanes, by rocketry. In 66 years, we got from no flight to walking on the moon. Cro-Magnon had pretty much the same technology for thousands of years. We're the same species as Cro-Magnon, no smarter, no more inventive. Why is there this explosion in the rate of technological change? Again, I will be showing you the beginnings of a theory that accounts for it. The same theory is telling us that we are racing into the Anthropocene, the unintended consequence of our very inventiveness. It's a Greek tragedy of beauty and destruction. About 2 years ago, I wrote down an equation which you see displayed before you. I call it, with my colleagues, the theory of the adjacent possible, or TAP, or the TAP process. It's remarkably simple, and even if one does not like looking at equations, this one's almost trivial in its simplicity. Here's what I was asking myself 2 years ago. Suppose there's an economy with some specific number of goods in it, say 40. How many goods will be in the economy in the next period, say the next year? So if the number of goods at time t, mt, is 40, the number of goods that will be in the economy at the next period is what we have now, 40, plus, and here's the fancy complicated stuff at the right in the equation, all the things that we can make out of our current 40 goods by trying to make something new and useful for any task out of any one chosen among the 40, or any pair of things chosen among the 40, or any triplet of things chosen among the 40, and so on. So this is, as Brian Arthur told us long ago, or in 2009, precisely the creating of new goods by combining old goods. To be concrete, the printing press of Gutenberg was a recombination between movable type and a wine press. The Wright brothers airplane is a combination of 4 things: a light gas engine, bicycle wheels, a propeller, and an airfoil. And it's intuitively obvious, the more things you've got, the more ways you can combine them to try to make something new, useful, and good for any specific task. That doesn't mean you try them at random. You intelligently choose among things those that might be useful to do any specific thing. Another way of thinking about this is to use the notion in English of jury rigging. Suppose that you need to fix some problem that's come up in your house, and you go to the garage to find something that will help you fix it. Would you rather have one thing, a broken rake, in your garage, or a few hundred things stuffed around? It's obviously easier to jury rig with lots of things to try to, quote, fiddle together than a few things. That's all this equation says. A limitation of the equation is that right now nothing ever disappears. I'll return to that. So you will also see on the screen what the funny symbol MT and under it I in brackets means. It just means MT choose I is if MT is 10 and I is 2, it's consider all pairs of things chosen among 10 things. and that turns out to be 10 factorial divided by 2 factorial times 8 factorial, and you all learned in high school 10 factorial is 10 times 9 times 8 times 7 times 6. So it's really just arithmetic. There's only 2 parameters in this little equation. One is the initial number of goods, m0, times 0, and the second is this little symbol alpha I. Alpha I is simply capturing the idea that it's relatively easier to make something out of one thing than out of pairs of things, and easier to make things out of pairs of things than out of triplets of things. But there's a lot more pairs of things than single things chosen out of 10, and a lot more triplets of things chosen out of 10. So that's the equation. It has remarkable properties. As far as my colleagues and I know, the TAP equation is new. It's not been written down before. There are theorems about it due to Mike Steele, a mathematician in New Zealand, and simulations of it due principally to Wim Hordag, that show the following. The TAP process is such that if you start with a small number of initial goods, say 10 or 20, for a very, very long time, the number of goods remains very low and they remain of similar complexity. Then all of a sudden, there's a burst or hockey stick upward. That is an explosion upward, and the process, quotes, reaches infinity at some finite time. That means that the curve upward goes vertical. There's a singularity. Well, we think that this process explains how we got from 10 goods and a few thousands of goods to billions of goods recently, for which otherwise we have no theory. The import of this, among other things, is that no process on a finite planet can reach infinity, and this racing upward towards infinity is precisely the current Anthropocene that is enriching us all and destroying the biosphere. I'm currently showing you a figure based on very good data from the Madison Project, showing global GDP from the year 0, the time of Christ, to now. As you can see, it stays essentially flat for a very long time, then hockey sticks upward starting around 150 to 200 years ago. So the next question is the following. Can the TAP process, the TAP equation, hope to explain this glacial increase in GDP, global GDP, then its explosion upward ever more rapidly? The answer is quite striking. Yes, the TAP equation can fit the observed pattern. Now I need to be careful, it doesn't predict the pattern. We've had to tune our 2 parameters, the initial number of goods and alpha I, to get the results that we have above. But that doesn't mean that the TAP process cannot explain what is going on. Our getting from tens of goods to hundreds of goods, slowly to thousands of goods, and the explosion upward in the recent past to billions. Again, as far as I know and my colleagues know, there's no other equation or process that hopes to explain this. So the tentative conclusion is the TAP process, which is just humanity and the hominid line for 3 million years, typically doing nothing but keeping what is lying on hand that works and carrying it forward over time, and trying to innovate by using what lies to hand to build new things out of what's around. So if there's 10 things, you try to make new things out of single things or pairs of things or triplets of things. And we've been doing it for 3 million years. This is presumably cumulative human technological evolution and cultural evolution over the past 3 million years. Therefore, it's plausible that the TAP process is capturing something deep about how technological and cultural evolution really works. The same TAP process predicts another major feature of our technological and economic evolution. Per capita GDP, wealth per person, stayed flat at about $300 to $400 per year, surely for the past 2,000 years, almost surely for the past 300,000 years, and perhaps before Homo sapiens rose. and it exploded upward in the past 250 or 300 years. So there's a hockey stick in per capita income. Well, the TAP theory predicts it, or can predict it, because of the following. To get per capita GDP, you simply divide global GDP, which the theory predicts, by population size, and that gives per capita GDP. That, in fact, yields a hockey stick. As you can see, it's true that per capita GDP was utterly flat for years, and then it exploded upward about 150 or 200 years ago. Now, this also explains something fundamental about hominid and Homo sapiens evolution, which is the following. Because global GDP and per capita GDP stayed flat until a few hundred years ago, maybe 1,000 years ago or so, if population increased somewhat, but income did not increase, population density rose above survival level, and the population died back. So for hundreds of thousands of years, the human population is held low. This is the Malthusian world of starvation, and it's true. But about 150 to 200 years ago, the TAP process exploded upward, per capita GDP exploded upward, and the essential issue is that per capita GDP rose faster than the human population could rise. Therefore, the human population could begin to explode without per capita GDP collapsing. This is the great transition that has led to the emergence of 7.7 billion humans on the planet. We think it's broadly explained by the TAP process, augmented by other things. You must have a population of very many people to maintain a diversity of billions of things. So population growth is important to the success of the whole process, and cultural transmission from generation to generation, cultural learning, innovation, and so on are all major aspects of this that are not themselves described by the TAP process, which is something like a logical skeleton for the process. Another implication of the TAP process is urbanization. Urbanization is also a hockey stick. For thousands and thousands of years, human populations lived in the countryside with at most small urban settings. Urbanization really only exploded starting about 1850 or maybe 1800, a little before. I show you this in the next slide, but the issue is the following. It turns out that there's very good data that the fraction of the population living in urban settings scales with the logarithm of per capita GDP. Per capita GDP is a hockey stick upward in the last few centuries, so the logarithm of that is also a hockey stick in the last few centuries, and the shape of the TAP process, we believe, explains that. The next image shows us urbanization over the past 2,000 years. As you can see, it hockey sticks upward, just as we now expect about 250 years ago. It's now expected that by 2070, 60 or 70% of humanity will live in vast megacities, unfortunately probably surrounded by slums of agonizing poverty and inequality. I want now briefly to turn to a second use of the TAP equation. It's simply this. At any stage, let m of time t not be the number of goods, but the complexity of the most complex good produced in the economy at that time. With this different understanding of the same TAP process, we make new, more complex goods out of existing, somewhat less complex goods. You cannot make a crossbow until you have a bow. You cannot make a space station until you have rockets. With this understanding of the TAP process, what has happened over time is that the number of goods has increased glacially, then exploded upward, but also their differentiation into simple and more complex good has increased glacially and exploded upward. As I've already noted, this is Australopithecus with 10 crude similar stone tools, to 50,000 years ago, Cro-Magnon, with a few hundred tools ranging in complexity from arrowheads to atlatls, the spear thrower, to Mesopotamia with thousands of goods ranging in complexity from needles to chariots, simple to complex, low value, high value, to us now with needles and space stations, low value per good to enormous value per good. With the emergence of the differentiation of tools into simple and complex, more valuable goods, one gets the underpinning for the emergence of human inequality, which has been growing since the Neolithic, where my colleague Tim Kohler has found evidence for differentiation in Neolithic village sites and burial sites between simple graves and very complex graves with adolescent skeletons carrying necklaces with thousands of shells gathered from hundreds of miles away. Those sites from maybe 15 or 20,000 years ago tell us that already by then, human differentiation into simple and complex, wealthy and less wealthy, inheritance, there are teenagers that are being buried, presumably power structures, were around 30,000 years ago. There's a book called The Great Leveler, in which the author points out 10,000 years of archaeological evidence for the increase in inequality and collapse. Tim Kohler has recently published an article talking about 3 waves of growth and collapse in the American Southwest. If violence and collapse occurs as resources dwindle in the American Southwest, what is going to happen as we confront the Anthropocene with flooding, migration, and the extinction events, the loss of food as desertification happens? Again, our task and problem is civilizational, it's global, and it's truly existential. I end with the final image. It's the image of the Anthropocene. One may doubt whether the Anthropocene started 30,000 years ago, perhaps 8,000 years ago, when we domesticated grasses and began to own lands and there was excess wealth, or with the atomic bomb in 1944. There's no doubt that the Anthropocene is upon us. The issue now is, will we confront it? What will we do? The summary is what I started with. Bluntly, our magnificent global economy, $100 trillion and growing at 3 to 4% a year, expected to be tenfold larger by 2100, is lifting truly millions from poverty. It is linking our nations around the globe in trade, and it is providing all of us our means by which we earn our living. The same juggernaut global economy is driving climate change and is driving a mass extinction event. What will we do? I think we don't know. It's not obvious that we will be able to alter our own juggernaut global economy. We have never faced anything like this. We face it now. I want to talk briefly about the role of the United States. These are enormous issues. The United States is the largest economy in the world, and it needs to be vitally present, playing a leading role in helping confront climate change and extinction, and trying with all the people on the globe and understanding what we're doing. Unfortunately, our current president, Donald Trump, has removed the United States from the Paris Accords. Trump believes climate change is, quotes, fake news. Of course, he's wrong. There's something very interesting that the Trump administration is doing that bears comment. At the same time that Donald Trump declares that climate warming, that climate change is fake news, the Trump administration under his leadership is preventing US agencies, such as the EPA, NASA, NOAA, and so on, from publishing their scientific results that show that climate change is real. Now, if Mr. Trump really thought that climate change was false, you would think that he would allow US agencies to present the new results that say that climate change is false. That's not what's happening. Donald Trump, as President of the United States, is lying to the world, and he's lying to the American people by not allowing U.S. agencies to publish the evolution that, in fact, climate change is real. I hope people bear this in mind. Let me conclude. Thank you for listening. Humanity has never confronted issues on this scale. If we fail to understand what we will do, we will face untold consequences. Thank you.